All right, let's run another one. New question. This one I'm telling it specifically to do an Algebra 2 problem. Let's see what it has for us. Systems of equations. I think that might kind of be Algebra 1, but we can do it. Okay, let's solve the systems of equations. Cool. So we've got 2x plus 3y equals 7. So we've got 2x plus 3y equals 7, as well as 4x minus y equals, is it -3? Cool. So here are two equations. When you're dealing with systems of equations, there are three ways, I think, typically that we solve these. One of them is substitution. Another is elimination, and you can solve by graphing, which you'll see sometimes. This one, when I'm looking at it, substitution looks like the easiest one to use. So I'm going to show you guys how to do a little substitution. So this equation right here obviously has x and y in it, and the other equation has x and y in it as well. So we can't solve an equation that has two variables in it because we're just going to get one variable in terms of another variable. So we have to figure out a way to get rid of one of the variables. And one of the ways to do that is by solving one of the equations for one of the variables and plugging in the information into the other equation. So I'm going to do that with this bottom equation. I'm going to solve for the y. So I'm noticing that this y is all by itself. So if I add y to the other side, I'm going to be able to isolate this y if I can get rid of that -3. So I'm noticing that if I add y to both sides, I get 4x equals -3 plus y. And now again, I want to get this y by itself, so I'm going to get rid of this -3 by adding 3 to both sides, giving me 4x plus 3 equals y. And now that I have something that equals one of the variables, I can take this right here and plug this in for the y in the other equation. And that's where the substitution comes into play. We're substituting this thing that we made equal to y in for the y in the other equation. So that's going to give us 2x plus 3. And now instead of the y, we're going to write what we found is equal to y. So 4x plus 3. And that's going to equal 7, which is what it equals in this equation. All right, in order to solve this equation, we have to first distribute the 3 into the parentheses. We want to get rid of the parentheses first so we can deal with everything else. So we're going to have 2x plus 3 times 4 is 12x plus 3 times 3 is 9. That's going to equal 7. We can combine like terms on the left side of the equation. So 2x plus 12x is going to equal 14x. I don't know why I dragged out the 4 like that. 14, you know. And then we got plus 9 equals 7. And then I'm going to subtract this 9 over. That's how you solve an equation like this. It's going to equal -2. And as I feared, this is going to be a pretty ugly number. So now we just have 14x equals -2. To solve the rest of the equation, we divide by 14, which is going to give us a pretty gross fraction. -2 over 14. 2 and 14 have a common factor of 2, so I can actually divide both of these numbers by 2 to simplify this, but it's still pretty ugly. X is going to equal -1/7, and I'm assuming that y isn't going to be much prettier. So now that we have x solved for, we can use substitution again, substituting x back into either one of these equations. I think the bottom equation is going to be easier to solve, so let's go 4 times x, which we now know is -1/7, -1/7, and then minus y equals -3. And we want to solve for this y again, so we can actually kind of do what we did over here. Add the y to this side, add the 3 to this side. So we're going to kind of end up actually using this equation. So it's 4 times -1/7 plus 3 is going to end up equaling y. And then 4 times -1/7 is -4/7 plus 3 equals y. So y is going to equal 3 minus 4/7, which is going to leave us with 2 and 3/7, sorry. And that'll be our pretty disgusting answer. If we plug these back in, it should work in both equations. Kind of just proved it with this one, but it should work with the other equation as well. And that's the answer. Thanks for watching. Catch you later.